Hello, ma'am. Hello, sir. Today I've done the project of integrated digital analytics for store optimization. This project type is EDA regression and classification supervised. This project developed a machine learning system to predict weekly retail sales using horizontal data. The goal was to help retailers forecast demand accurately for better inventory staffing and prompting planning. The key steps is data processing that cleaned missing value, handling outliers, and so on, so on. Then I've done the EDA, used 8 visualization like histograph, box plot, correlation, heat map, etc. to uncover pattern. Found strong prediction like marked on one temperature and is holiday. Discovered seasonal trends. Higher sales during holidays and summer and all. That I'll explain further on. Features of featuring engineering. I created a new feature like is holiday flags, is holiday flags, time-based variables like months, week of year, and markdown ratios reduce feature correlation using technique like PCA. Speaking about model development, I trained and compared three models. That is linear regression and linear regression, random forest, and XBoost. And I selected XBoost because it's for 92% R2 accuracy. Optimize the XGBoost using random search CV for hyperparameter tuning. And for deployment, I built a Streamlit web app for real-time prediction, single input or batch CSV upload, including feature like importance visualization and error handling. Speaking about business impact, it enables retailers to forecast sales with 92% accuracy, helps optimization inventory, staffing, and promotion, identifies key sales drivers, example holidays, markdowns. Tech stack I've used is Python, skitlearn, XBoost, Pandas, and Streamlit. Now I'll move on to the project. In the beginning, I imported libraries, data set loading, and everything that is needed. This is the data wrangling code. Moving on to the charts, that's the EDA. The first chart is given here is histogram. It analyzes the distribution of weekly sales to identify skewness and potential need for long transformation. Moving to the second chart, I use boxplot. It detects outliers in weak sales and confirm holiday sales spikes as valid data points. The third chart derives this correlation heat map identifies strong correlation between weak sales and feature like markdown one temperature. The fourth one is scatter plot. Visualize the relationship between markdown one and weak sales, revealing non-linear patterns. The fifth chart is time series line plot, and it uncovered the seasonal trends in sales with clear peaks during holidays and summer months. The sixth chart is missing value heat map. Visualize the missing data pattern showing 20% missing values in markdown columns. The seventh chart is group by plot. Compare average weekly sales by store type, showing type A stores had highest sales. And the last, sorry, chart number 7. This is chart number 8, which is holiday impact by plot. Quantifies the 20 to 30% sale increase during holidays. Emphasizes the importance of each holiday feature. Is all tokenization and text normalization I've done. Now moving on to ML model implementation. The first model that I've implemented is the linear regression baseline model. The type of is parametric linear model. The purpose of it is establish a performance baseline for comparison. The assumption is the linear relationship between feature and target, normally distributed residuals, and non-multicollinearity. Speaking about the pros of this model, it's simple, interpretable, and fast to train. Works well with linear relationships. Now, speaking about the cons of this model, is the poor performance with non-linear relationship and sensitive outliers. Now, uh, I'll speak about the implementation in project. It copies from skill and linear model import, linear ligation, and the performance. Speaking about the performance, the R square value is approximately around 0.75. Yeah, baseline. The use case is served as simple benchmark to compare against the more complex model. Speaking about model 2, random forest regression. It the type resembles a nonlinear model. The purpose is to capture nonlinear relationships and feature interactions. The key characteristics that I've shown, how it works. Builds model decision tree during training, outputs the average prediction of individual trees. Now, I'll speak about the pros of this model. It handles non-linear relationship well, robust the outliers and missing values, provides feature importance scores. Speaking about cons, can outfit if not turned properly, slower than linear model for large data set. The performance that I've got is approximately around 0.87, better than the regression model, but the use case is demonstrate the value of non-linear model for this data set. Now, a final model. It model number 3, XGBoost regression. The type of it is assembly gradient boosting model. The purpose is it achieves highest accuracy with optimized performance. How it works? It sequentially builds tree to correct errors of previous trees. Use gradients descent to minimize loss. Speaking about advantage of random forest, generally it's more accurate, includes regularization to prevent outfitting. It handles various data types well. And I'll speak about the pros first. The state of the art performance for structured data handles non-linear relationship exceptionally well, building cross validation and regularization. Speaking about cons, more hyperparameters, true tune, slower training than random forest, but high accuracy. It gave me the accuracy around 0.92. And I selected this model as final model for deployment due to superior accuracy only. Saving the work, and again I'll just speak about why I chose this model. Because of highest accuracy, obviously, which is 0.92, and the lowest MSE. It handles complex patterns, captures non-linear relationship and features interaction effectively. Regularization is built-in mechanism to prevent overfitting. Speaking about feature importance, it provides the insights into the key sales drivers, example markdowns, temperature. It is scalable. It performs well even with larger datasets. Now I will show you my deployed model, which is using Streamlit. So this is my actual model, this weekly sales prediction app. Here I've already uploaded my test sales data. The feature one, that is temperature, I've put it at 75. Feature one, feature zero is 75. Feature one is 3.25. Feature two is 130. Feature three 8.5, and feature four is 1,500. 15,000. Sorry. So I got the predicted weekly data sales is like 1.33, which is by using the model XGBoost regressor. And performance optimized using random search CV, as I've told before. And use case, it predicts weekly sales for it also. I'll do the same thing for here. I've given two methods like input features and batch prediction. This like to upload CSV file. I'll just put the feature. So as you can see, the prediction of weekly sales is 1.33. You can see the paragraph over here also. The importance is given over here. And this is all for my model. Thank you.